for the final exam, this is going to be like last semester. Last semester, what I did was the multiple choice portion was the final, and then the free response questions were bonus. And the free response, this is 10% of the final. Points total. So I think I had the final exam worth 200 points, but I didn't quite get to 1,000 points of this semester. So if we did, let's say, 800 points, it'd be worth. The final exam is 20% of the total grade. And so I have to tabulate the grade total, how many points we had, and then I'll make the final exam 20% of that. Out of that, let's say the final came out to 150 points. If the final was worth 150 points, then you would get 10% of that as a bonus. So the bonus would be worth 15 points. That would be the free response part. Does that make sense? So some people last semester, because the free response was bonus, they didn't even bother taking it. They skipped it. But I don't recommend doing that because unfortunately they didn't do so well on the multiple choice part, which can be tricky. And so they might have been able to get some partial credit, had they taken it. All right, for the free response part, those are usually things that are difficult to test with multiple choice. So with the free response, what I like to do is I like to have chemical reactions there. Well, for the chemical reactions, you're going to have an example. I'm not sure if I'm going to put each of these, but like a metathesis reaction. If you have metathesis, then you need to know the solubility rules, in case there's a precipitate or something like that. But it's always a trade-off because, let's say you have no idea what the solubility rules are. Is it worth spending a lot of time cramming for it? It depends. It depends on what proportion of the test. If you look at the points overall, maybe not. But there's metathesis. And then you're going to have perhaps acid-base, and then redox, of course. Redox could be skeleton or the chart method for redox. For redox and acid-base, you're going to be given the redox acid-base chart. And so we'll just have some chemical reactions, and these chemical reactions we're not going to predict like delta G or anything like that. We're just going to see, is there a driving force for that? Like the driving force for metathesis was precipitation or gas formation. Same thing with acid-base, stronger acid to weaker. But for redox, it has totally different driving force. A stronger oxidizer, stronger reducer to weaker oxidizer, weaker reducer. Totally different. Gas formation and precipitation, a lot of people got this wrong on the exam earlier in the semester, when I asked about driving force for redox. More people got it wrong than I was expecting, because a lot of people said that precipitation and gas formation were driving forces for redox. They aren't driving forces for redox. And so go back and look at that. So things like chemical reactions, I usually put some chemical reactions on there for the FRQ. And then for other questions, I put things like, I'm not saying this is going to be on there, but I've asked this in the past. Draw, like, for example, the zinc copper cell. You know. I might give you a cell diagram like this: Zn solid to Zn2 plus, copper 2 plus to copper solid, under standard conditions. I might ask you to sketch this out. You know, I didn't talk about this, but this is the sometimes happens, you know, on exams. Not so much. I tried not to do this too much because it causes. This would be an example of yeah. But this would be an example of something where, you know, the instructor didn't talk about but could throw on the test. You know, I always prepared for that when I was a student because it happened so frequently. You know, that the question on the exam wasn't exactly anything that we had encountered in class. And so mentally I would be thinking about this type of stuff. So you know, in that case, I kind of ran out of time, so I didn't talk about concentration cells in that much depth. But you could actually have a cell like this, where it's copper solid, you know, copper 2 plus, copper 2 plus, and copper solid. And you look at a cell like this, it looks like nothing's going to happen because you have copper 2 plus trying to oxidize copper. You know, it's going to be a dead even tug of war, right? And so under standard conditions, this is 0 volts, as you'd expect, you know, under standard conditions. But under non-standard conditions, then you could get a voltage from this. You know, so this would be an example of something that, you know, the instructor didn't talk about, but was thrown on the final to see, you know, could you figure this out? So for example, if I made this one, let's say I made this one 2 molar, and I made this one 1 molar, what would happen? Could you calculate the voltage for this? You know? And so, yeah, we could just use the Nernst. Under non-standard conditions, it would be something like this. E of the cell is equal to E naught of the cell. Well, E naught of the cell is 0, you know, plus 0.0592 volts over N times the log. Now, this is going to be the log of the copper 2 plus product solution, the anode, over the copper 2 plus at the cathode. Product over reactants. As we get the log of 1/2. So we would generate a voltage here. In other words, this is an uneven tug of war. It's copper 2 versus copper 2, but one side has twice as many. And that side is going to win the tug of war. So I didn't really do this much, but those are the things that, you know, it's based on what you've done before, but it's different. That's all. I don't think I'd do that on this. What I would do on my test is it's just recall. Can you recall what we did in class? Can you recall what you did in the homework? You know, recall. And like I said, recall is like 90% of the tests that I took. 90% of the tests I took at UCLA were just recall. You could remember it, then you had an A. Then if you could extend your recall knowledge like this, you know, so for example, if the instructor never talked about concentration cells but threw in a cell like this, would you be able to figure it out, or would he throw you for a loop, you know? type of stuff. Well, speaking of recall, what else could we do here that's not so multiple choice friendly? And what else we could do is isomers. And isomers are what we're going to talk about today. And we're going to have a lab for isomers. So it depends. You know, I could have a few questions worth a lot more points or a lot of questions worth fewer points. Normally I do a lot of questions worth fewer points. That way, if you don't know something, it's not going to kill your grade. But for this, I don't want too many questions. I'm not gonna probably have like 4 or 5 questions. It's not worth that many points, you know, depending on what the point total comes out to. Now, the point total I have to figure out because I want to see what you guys want to do. What I can do for the final 2 chapters, so the final 2 chapters are going to be chapter 24, part 2, and then chapter 25, which is nuclear chem. I was going to put some short homework assignments for those. Those would be worth 10 points each. But, you know, sometimes I think, okay, those are going to be relatively short. And so I think it could be helpful. But what happens is a lot of people don't end up doing those. And then it becomes somewhat of a drag on their grade, an anchor, causes them to sink. So I'll see what you guys want to do as far as the homework sets, chapter 24 and chapter 25. Do you want some homework sets for that, or do you want me to just, because I can omit those out of the final grade, you know? And so it might be helpful or it might be harmful. And so I can go with either, because if you just study the notes for that, then you should be able to answer the questions on the final. You know, the questions on the final are just going to be based on what I talked about in class. I'm not going to extend it out like this, concentration cells or pH cell. pH meters work in this way. You can set up a concentration cell. The old pH meters worked in this way, where you'd have an SHE on one side and a hydrogen electrode on the other. And then you can measure how much H plus there is, you know. But let's take a vote. Do you guys want additional homework? 2 sets? Or skip those? Well, how many people want to just have those? All right. Yeah, then it looks like the majority of people. So I'll just put them on there. I'll put them on there today. That'll be 20 points worth of homework. All right, so do you remember the stuff? The chemical reactions, I'm going to make it even simpler. For the chemical reactions, I'm going to make those from the qualitative analysis lab. I already wrote all the equations on the board. So nothing new. All right, the other thing regarding the points, the final points that I need to tabulate the score for the final is for the pH titration report. I was going to do something similar to what I did with the synthesis lab. Last semester, I had my students write a formal report also, but something didn't quite get through. A lot of people had the format all screwed up. They didn't have an abstract, intro, all this stuff. So this semester I thought, okay, I'm going to do it differently. I'm just going to tell you what I want. And if you can put everything that I want in there, then you'll get an A on the report, basically, because you won't be missing anything, and the format will be what I was expecting, not some crazy format. And I saw some crazy formats last semester. People, I just had no idea where they got the idea for the report, and the information they put into the report was bad. But, you know, since it was a formal report, I didn't knock off a lot of points off those, although I wanted to knock off a lot of points. So this semester was kind of weird. I know some people complained about this, that, okay, I'm writing the report for you, but when I write the report, that's a rough draft. You know, I expect you to clean up you can change the language. You don't have to use it verbatim, and I don't expect it verbatim because it wasn't really polished. You know, you can polish it up if you want, or you can just leave it. Even if you leave it, everything's there, except for the introduction. The introduction you have to figure out, you know. So the formal reports are worth 30 points, but it depends on where you're at. Has everybody figured out what their unknown acid is? Pretty much. And so I figured that, you know, the things that I was looking for that, let me talk about that now. For the pH titration, isomers we're talking about today. Let me move this. I don't know, some of the videos have failed processing, and I'm not sure what's going on, but do people want the videos up? Try to get some videos up, or, yeah. I haven't posted any videos in a while. Yeah. I'm sorry, what was that again? Yeah, the free response questions, yeah. So I was going to do a similar thing with the pH titration, just go through the entire report. I don't know if you found that helpful or not of any value, you know, going through the report.
So basically, just kind of wants to polish what you already
Right, right. We have, for the synthesis, you know, you can just write it in your own words. You know, that's what we do. Oftentimes, that's what I did. I remember doing that in English composition. We'd take a famous passage and then just tweak it. But we would copy it verbatim, and then we'd continually tweak it. I don't know, have you ever done that? We did that a lot in English. This was at UCLA. Uh-huh.
like Russians, like the
Yeah, you just put in an introduction section there. You don't even have to tweak it. You should get full points if everything's in there. I don't, you know, if your grammar or your spelling is off a little bit, I'm not going to deduct points for that. So I'm just looking, do you have all the information that I want in there? That's it. And the same thing with the pH titration. You have two choices for the pH titration. One, we could do another formal report for this, or two, you just tell me what the acid is. If you just tell me what the acid is, I'll put all the points into your acid identification.
Let's just do that.
Just tell me what the acid is?
I don't have time for a whole game there.
All right, that's fine. So for the pH titration, just tell me what acid you found for this. You don't have to tell me how you identify. The reason I have people write a formal report for this is because sometimes they don't get the acid. They screw up the acid identification, and then I can still give them a lot of points depending on how they analyze their data. You know, if it made sense that they misassigned it because, or if they made some kind of gross error in the assignment, like they screwed up the calculation or something like that. If we're gonna just do the acid, since that's all or nothing kind of thing, but you'll get credit for coming in and doing the lab work, of course, but all the points are gonna be wrapped up into your identification, most of them. It's not gonna be like 0, or it's not gonna be 30 points anymore. I'll make this worth 15 points, just like a normal lab. 15 pointer. Yes, it would be 30 points as a formal report. Well, this is another thing. You know, it depends on how much time you have, but this could be damaging for some people. Like some people in the past have not turned in any report, or they turned in like a half a page or 1-page report. You know, I think they just ran out of time. And so it depends on how much time you have. If you have enough time, then you could do a 30 point. This one I can make do after the final, you know, if that helps. But
do we not also have a non-formal report for the qualitative analysis?
the quality,
You went like through all the reactions into a non-formal for that?
yeah, we do. We do have that. I already did it. I already did all the equations. All you have to do is tell me what the unknown number was and a list of cations that you found. I would think it would only take like 5 minutes, but I'm not sure how long it's taking people to do that. You know.
Especially, yeah, we're gonna do
The reason I do that is so all the points aren't. A lot of people screw up qualitative analysis. They don't get the correct cations, or they find extra cations in there, and so a lot of people screw up the qualitative analysis. So that's why I'm wrapping up a bunch of points in the equations. And so this is actually a good review for the final. You know, just rewrite the equations. Don't just rewrite the equations, and then you should be prepared for the free response part of the final, I think. And then turn it in on the day of the final on Monday. Turn it in to me. Yeah. The lab notebook is worth only. It's not worth that much, you know, 5 points. But have you guys been maintaining your lab notebook? Yeah, I'd like to see what people write in their lab notebook. Some people, they don't maintain the lab notebook, but it's not worth that much. It's worth 5 points. Some people have beautiful lab notebooks, so I just like to see those at the end.
Just to double check, you said that rewriting the equation for the qualitative analysis is really good practice.
Yeah.
So I just wanted to make sure.
Right, I think that's good practice. I mean, it's not that you should memorize. I would think that whatever chemical reaction I give you, you should be able to figure out. I don't expect you to just memorize there are a lot of equations in qualitative analysis, so I don't expect you to memorize those, but I think, you know, if you can kind of see, my philosophy about this is like the more examples that you see, especially in beginning classes like this, the easier. I don't believe in like focusing on one question or 2 questions. And then this is why I think like looking at the homework, and I know some people looked at a lot of the homework assignments beyond what were assigned in the chapter. Actually, I don't think I assigned very many from the chapter, but you know, those can pay off. It depends. You know, sometimes you get questions that are nothing like the homework. I mean, that happened to me all the time. I mean, I was to be expected, actually. Questions that aren't like the homework and that aren't like whatever they talk about in lecture. That happened all the time. it happens so frequently that my classmates never complained about it. You know, it's kind of expected, you know. Initially they did, of course, everybody complained initially, but once you get used to it, that's kind of the case, then that's it. But this one is going to be similar. I mean, in fact, it's going to be exactly. I'll just pick a few reactions out of there. You know, worst case scenario is you just memorize them. But that's hard.
So what you're saying is that the response question, like, you're gonna choose one for qualitative analysis.
In other words, for the free response, you don't have to mentally prepare for something that you've never seen before, right? Because you prepare a little differently versus recall. For recall, you just review your notes, review whatever, review the lab. You know, you have a little bit different strategy for that than if you're going to be hit blindside by some problem that is going to throw you for a loop. That's the difference, I think. And so what I'm telling you is that you're not going to see surprises like this. This might be a surprise for some people, seeing a cell like this where the anode and cathode are the same thing. Right? If the anode and the cathode are the same thing, then what are you doing? Well, under standard conditions, you're doing nothing. But under non-standard conditions, you could be doing something. I could put 2 molar on the left, 1 molar on the right, and you'd have to tell me, well, that cell's not going to operate. The electrons are going to try to go backwards, which is fine, you know, but you have it written differently because the anode is written first and followed by the cathodes written second. So I could have done that. You know, I could throw you for another loop by changing this to 2 molar here, 1 molar here, and then ask you what's going to happen. But you're not going to see, the whole point of this is you're not going to see something like this for the free response. In fact, the final, all I want to do, and this is my philosophy for the final, is did you get the basics down? And so that goes for the multiple choice. Some people are asking me for like a practice test for the multiple choice, but just look at your old multiple choice questions from your old tests. You know, the questions are going to be very similar to what you've seen on your past exams.
I just wanted to ask you, you also listed the exams.
I did, yeah, but they're on the file,
Oh, they're files.
under files, yeah. Blank ones. I have the keys too. I'll probably post those this week for those. But yeah, I think that, and then for the last, like the electrochem, I mean, this is kind of a lot of the electrochem here. You know, we have this shorthand method, which is called the cell diagram. But I would want a drawing. You know, you draw a beaker for the anode and the beaker for the cathode and attach them with a wire or something like that. In the past, I've given electrolytic cells too, but not sure. If I do that. In the electrolytic cell, I just draw it as is. You know, draw the cell, and then we'd want to know what the cell voltage, the standard cell voltage is, and maybe non-standard cell voltage for this. The equations, you don't have to memorize the equations for the Nernst equation, for example, or the thermo equations. If you need an equation, I'll just give it to you. Well, that goes for constants as well. If you need a constant, I'll just give it to you. So the point of this is that for preparing for this test, it's just a recall test. The multiple choice, the free response, it's all recall. It's not going to be a challenge, you know, type question. I used to, when I first started teaching, I used to put a lot of challenge questions in there just because I was used to that. And then I had one of my students, actually wrote me a very, very long letter that, she was saying, what was I trying to do? Was I trying to do some kind of psychological operation on her, like something? And, what was the purpose of this? Because every question I asked was not a question that we ever covered. And then I thought, she's right. Every question I had asked, and I purposely did that because that was what I was used to. I was used to this, and I was used to always preparing for tests that had questions that were nothing like what were asked. So to always throw in questions that were like that. And I figured, what's the point of doing that? And then I changed after that. That was right when I first started teaching because I was still quite accustomed to that. But anyway, so this I just want to hopefully be like the basics of this chapter. All right, so for this pH titration, going back to this one, if you wanted to do a formal report, then you have a choice. You could either just tell me what the acid is, that's going to be worth 15 points, or if you want to, you could write a report for this, but the report would be, if it were perfect, they'd get 30 points, but a lot of people are going to miss points for this because there's a lot of things that they need to include into that. And so if you wanted to do a formal report for this, I'll post a video showing what I want in there. And then I'll give you some bonus for that. Yeah, you would do it with your partners, okay. It would be co-authored. Actually, the bonus would be too much for this. Maybe I'll keep it at 15 points bonus, but I won't tell you how to write it. You'd have to figure out how to write it. Yeah. I'll tell you what I expect to find in it. Yeah. I'll tell you. Yeah, it would be like last semester, except there's a lot more in this particular report. So for example, you would, when I think about this acid report here, the first thing is it mono or diprotic? And how did you analyze that? So in the discussion, I'm going to have to see this. In the abstract, of course, you're going to write briefly how you did this. In the discussion, a more thorough analysis of how did you figure out whether it's mono or diprotic. Okay, the second thing is the equivalence points. The equivalence point you're going to get from the pH versus milliliters of titrant. That's going to give you an equivalence point. And then we're going to have the first derivative plot. That's going to give you another equivalence point. Hopefully they're exactly the same, but most likely they aren't exactly the same. Okay, then you're going to get an equivalence point from the second derivative. Was the second derivative even worthwhile? Some people's second derivatives are so noisy that they're worthless to analyze. But, are we going to get into something that's consistent? We know from the first two what we expect to find at the second one. And even if the second derivative were worthlessly noisy, at least it could be consistent with the first two. Okay, and then which did you use for your calculation? Which did you use? And why? Usually, for mono, we analyze the equivalence point or second equivalence point for di. We do the second equivalence point for dye because that's more pronounced. And so you could say that you analyze the second equivalence for the dye because it gave you a larger signal. You know? And then for diprotic, what we can do is we can divide that in half and see, did the first equivalence point come in at half the second? You know, and so you can kind of measure it and then compare it with what we expect. So for diprotic, the first, we have 2. It's going to be 1/2 the second, and we can get it from the plots. Did they agree? If not, what are you going to say? You know, if so, then that's good because that's extra additional evidence for this. Getting back to this, which did you use? Did you add the 3? For example, did you combine the 3 and divide by 3? Or did you just take the first 2? Because the third one was inconclusive? Or did you just take the first one, or did you just use the first derivative? On the plots, I expect to see the figures. The figures have to be analyzed. So I'm going to look at your plot and see where you pinpointed the equivalence point, and then how you measured that. You know, some people are way off. So for example, let's say their data goes like this. Some people have a data point here and a data point here, but no data point at the equivalence point. And they pick one of these data points as their equivalence point, even though it's way off. This happens every semester. Somebody will do this, and then I deduct points for that. Because the equivalence point is based on the midpoint here, the inflection point. So this is wrong. This would be wrong too. There's no data point showing the equivalence point. The equivalence point would be right in the middle of this curve here. So I need to visually see how you analyze the graphs. This goes to the same thing with the first derivative plot. In the first derivative plot, sometimes people will have a data point here and a data point here, and they'll pick one of these. But really, what I told you to do was to fit this to Gaussian and then go off the peak here. So the figures have to be analyzed like this. These are the things I check when I grade it. You know, hopefully they agree, but in the comment, I mean, there's not much you can say, you know, that they're off. And so what did you do? Did you bias one or the other? You could, depending on which graph looks better. Or you might just average them. You know, if they came out close enough, just average it. All right, once we have the equivalence point, then we show the calculation in the discussion. And so do the calculation for molar mass. And then you do one. You do the percent error for nearest match. And then 2, you do the percent error for the next nearest match. Although it's unlikely to happen, it could happen in other scenarios where your best match was, let's say, let's go with something crazy. Hopefully your best match comes out closer than this, but let's say somebody got their best match at a 30% error, and then their next nearest match was a 31% error. 30% error versus a 31% error. Is the 30% error much better? I'd say both are pretty far off. So there could be something else wrong. And so I want to see the next nearest match here. Okay, then you would do the pKa. Analysis. And so I need to see this on the graph as well. For mono, if you have a diprotic, it's a bit more of a pain. Because we're going to have two pKa's. We're going to have pKa1 and pKa2. And then you would do the same thing, percent error for the best match. And percent error for the next nearest match. Then after this, we would go into how did you identify your unknown? How was this data used? To ID your unknown. It would be great if you had 0% error in the molar mass and 0% error in the pKa. Then it was what you call easy identification. But the problem is when it's not so easy, and this is what takes a lot of time. And you can talk about this. I mean, if one, let's say your molar mass was a pretty good agreement, but your pKa was not. Yeah. Then I had mentioned this multiple times because this happens frequently, that the pKa is a good match and the molar mass is a poor match. They want to go with the pKa because it's such a good match. They get a really small percent error. But I tell them not to do that because the pKa is less reliable than the molar mass. The molar mass is more reliable because the pKa depends on things like the pH meters, how they're calibrated, and how they vary. So for when you compared, we did that little experiment where everybody measured the pH of the same solution. Do you remember the range of pHs we got? The reason I did that was to show you for this pH titration lab that we can't have as much unless we do something else as far as the calibration goes. I mean, something's off. And so molar mass is definitely more, because even if your pH meter were way off, the equivalence points won't shift. The equivalence points will stay put. the graph will just go up or down vertically, depending on your calibration, but they won't go left or right horizontally because it doesn't change the moles of acid that you have, that you're titrating. And so, how is this data used to ID your unknown? You know, and then you talk. Maybe it was easy, maybe it was difficult. You know, you're always jealous of the people who have easy data. This happens in graduate school. There are some people, all their numbers work out perfectly, and then there's everybody else. Everybody else has a big headache in trying to interpret this. And then what you say, if there's still uncertainty, like it could go between one or the other, then you would write that, you know, that there's uncertainty, or how much confidence you have. You know, this is where you can talk about the confidence in your unknown identification. Okay, normally the conclusion is not a summary of it. A conclusion might be something like, well, if there were time, we would rerun this, you know, pay more careful attention to this or that. You know, the conclusion is usually what you would do in the future if you had more time and money, or advice that you give other people for doing this. All right, any questions on this? So you could do a formal report if you want as a bonus. It wouldn't be a 30-point bonus, it'd be some bonus.
Do we have definitive dates?
I'm sorry?
Do we have definitive dates?
Yeah, the due date, if you do this pH titration, then I'd like to collect it on, let's see. The 16th is our final. And so I'd like to collect it by the 18th. The synthesis lab, I'd like to collect that on the 16th. The qualitative analysis lab, I'd like to collect on the 16th. What other? There's one more lab you need. Actually, no, I don't think there is another lab. Was that it? The homework will be due on the 16th. Here. Late homework, I haven't been taking off a late penalty, just FYI, until I stop it. When I stop, I have to stop the assignment so I can collect the score totals, otherwise it won't give me the points. So when I stop it, and then if you turn it in after that, then it'll be assessed a late penalty because I have to go back and regrade everything. So I'm going to stop it on the 16th, and then if you didn't quite finish as much homework as you wanted to, you'll have up until the 18th to turn in late homework.
So our crystal paper and the qualitative analysis equation I do the 16th, and then the titration reports do on 18th.
Yeah, unless you just tell me what the acid is, I'm going to give you the option. You can just tell me what the acid is that you found, your unknown number and your acid. So it'd be a very simple report. It shouldn't take very long. And so that's due on the 16th. If you decide to do a formal report for the pH titration, then that'll be due on the 18th.
The one we typed together is due on the 16th.
What's that?
The one that we typed together is due on the 16th.
That's due on the 16th, right? That one, as long as you could write an intro section, then that one should be easy points, I think. You know? It was meant to be easy points, actually. So make sure you turn that in. Another easy points lab we're going to do today. And so let me talk about isomers now.